Hey folks, this is Andy Morrison, Advanced Cicerone and Product Specialist at Precision Fermentation. I'm going to be talking with you guys today about using real-time fermentation data to help drive things like consistency and efficiency in a beer cellar, and I'll be able to share some actual case study style stories from breweries that we've worked with in the last year and a half since we launched our product, to be able to talk about the effectiveness of using real-time fermentation data. So what we're going to talk about today is, I'll touch on the challenges that come with working with those traditional brewing methods or traditional sampling methods, and the traditional way that brewers often track data or the lack of tracking data. I'll talk about how our technology kind of fits into that, what real-time fermentation monitoring actually looks like in action, and then be able to share some of the stories then of breweries that have used that method that we have to be able to drive better efficiency or consistency over time. So obviously, as a baseline, what we want to talk about is just what do you track and what are you looking at during fermentation. So you've got this process that starts out with that lag phase, right? Where you're looking at oxygenation and the oxygen levels depleting over time. So you've got a variable changing there that then steps into active fermentation, where the yeast is consuming the sugar and gravity is changing and pH is changing as well as yeast is producing acid into the solution. As that happens, right, you're producing alcohol. That's the point of all of this. Of course, all of this is reliant on yeast, right? Which, if this was a simple manufacturing process, you could do it like baking and just toss in the right ingredients, throw it in the oven, and know that what's going to come out on the other side is going to be good as long as you held it at the right temperature, right? But yeast doesn't always, play along. Like, we've got to not only provide the best environment that we possibly can for yeast, but we've also got to continuously monitor that environment and monitor that process to make sure that the yeast is in fact doing what we want it to do. In practicality, what that means is, that you've got to collect samples during the fermentation in order to figure out what's going on. You've got to measure those samples across a number of different variables, right? And all of that comes with some challenges. So, as noted here, how frequently are you collecting data for your fermentations, right? And who's doing the data collecting? And is it consistent from one cellarman or QC personnel or whoever it is that you've got in your cellar that's managing that? From one person to the next, are you keeping it consistent? Then you've got all of the expense of the instrumentation, right? So in order to build out a true lab to monitor these things, you've got to have a whole store of different instruments to measure all the different pieces that you want to look at as you're doing that monitoring. And then once you've collected the data, all of that is just the process to actually collect data. Once you've collected the data, you've got to then actually manage that data. You've got to use it in a way that's effective, right? So it's about taking that data, plugging it into a spreadsheet, plugging it into some sort of database, graphing that, or charting it in different ways that are going to help you then be able to make decisions based on that data, right? And that's another layer of time and personnel that it takes, time and labor. So what that does is, give you an inefficient process that sometimes gets skipped or or corners are cut, right? And it means that you're waiting potentially weeks to figure out that something has gone wrong retroactively, where you're really working reactively instead of proactively, and you're relying on guesswork and just kind of popular wisdom, right? So, how many brewers out there have said, well, my beer always takes 6 days in tank, so I'm going to leave it sitting there for the first 3 or 4 days as long as the bucket is bubbling. I know something's going right, and I'm going to start checking gravities on day 4 just to make sure it's on track, right? And oftentimes we're doing that not out of laziness necessarily, but just because there's tons of other things that you're having to manage, right? There's a full brew schedule, there's personnel, there's purchasing the raw supplies. All of that kind of stuff, right, takes precedence sometimes to just checking on and making sure that your fermentations are working the way they need to. So what we did was at Precision Fermentation, we created this system that we call the Brew Monitor. It's a real-time monitoring system that tracks both the variables that tell you whether a fermentation is healthy, but also whether or not that yeast that's driving that fermentation is healthy as well. This system comes with 2 components. There's a physical sensor hub, the black box that you can see there on the screen, as we call it. And then a virtual console where all of the data from that black box gets streamed via your Wi-Fi into the console, and you have access to all of the data and analytical tools that are there. So essentially taking the idea of sampling and just dropping it in front of you with a layer of analytics that you otherwise wouldn't have if all you're doing is just manually taking samples, recording them somewhere, and leaving them to kind of collect dust. So it gives us the ability to also then build in sort of this real-time alert system and these comparative analytics that are kind of core to the system. So I'll show you what that means. What we do is we take this data at a high frequency. I'm going to talk through some of the variables that we look at. This is not going to be a comprehensive look of all of the variables that we look at. So you may hear me mention some other things that I'm not going to necessarily show you on the screen here. But the primary one, right, that we track is gravity. So every 30 minutes, our box is collecting a new gravity reading and placing it in front of the user. So you're getting this real-time look from pitch at the start point, 0 on the x-axis is the time that you pitched yeast, all the way to the end of the readings when you turn the system off, right? So you're looking at here a beer that started at about a 12-degree Plato starting gravity and finished somewhere around 3 degrees. What this gives us the ability to do, right, because we're taking these readings every 30 minutes, is be able to track along and show you, what this is on a much finer, in a much finer detail, right? So I'll get into this a little bit more, but it gives you earlier detection of the end of fermentation and early warning signs on stuck or stalled fermentations as well. So another key measurement that we're looking at is dissolved oxygen. This and the rest of all of the readings that we take are actually taken every 10 minutes. So dissolved oxygen obviously is a really important metric for measuring the health of the yeast within the first few hours of fermentation, right? It helps you measure, how much oxygen am I actually putting in? I was listening in to Bryn Keenan's seminar yesterday where she talked about, oxygenating about a degree or oxygenating 1 part per million per degree Plato. So, being able to measure that out pretty precisely is something that we're able to do in tank. So it's not in line. You're not taking approximations of how much you're oxygenating. It's a true measurement of what the dissolved oxygen level is inside your tank. So you'd be able to work on precise dosing, which we've seen from some breweries that we work with. But then it's also giving you a glimpse at how quickly that yeast is absorbed into how quickly the dissolved oxygen is absorbed by the yeast, and gives you an indication of how long, potentially your lag phase is going to last as well, right? The next one we're looking at every 10 minutes is pH. Obviously, the yeast is acidifying the beer as it goes. This is also an early fermentation lag phase indicator, right? We see that the initial pH drop happen pretty rapidly and then continue throughout the life of the fermentation. And this is pretty typical of what we see right here, right? We see that pH work its way downwards, and somewhere a few days into fermentation start to turn back upwards again, usually just before hitting terminal gravity. So it's a good indicator that you're pretty close to terminal. This again is also a good indicator of yeast health, just based on how quickly you're acidifying, and if you're acidifying at all. It's also something that is important to track because it is flavor positive. So you're going to see a case study a little bit later on where we saw an impact in the flavor of the beer that wasn't expected from a brewery, and we were able to look through these pH graphs to kind of figure out what had happened exactly. Another key thing that you're going to see that I'm going to call out during this is pressure. So we're actually reading pressure during the course of fermentation. What you're looking at here is hydrostatic pressure moving upwards a few days into fermentation. So this could mean that there was, a large addition of something, let's say fruit or additional wort, whatever it is, right? We can see these kind of micro changes we see when people are harvesting yeast, or you'd be able to see when you're dry hopping, for example. So why is all of this data important, right? And why do we take it at such a high frequency rate? Well, the idea here is that you're going to be able to use this data to develop a sort of baseline, or you'll hear me talk about benchmarking. And benchmarking is really important when tracking a dynamic process such as fermentation, right? So what's important is not that you're meeting some sort of universally accepted standard necessarily, but that when you're tracking data on fermentation, that each step along that path is recorded for your specific recipe that you're using, right? The specific fermentation profile, the specific batch of yeast or strain of yeast that you're working with, and even tank configuration, right? So all of those things can play a role in what these curves look like. So it's really about creating a fingerprint for a specific fermentation profile that you have, and then being able to relate things back to that fingerprint as you continue on with subsequent batches. What you're going to see me talk about then is going to be kind of comparative graphs, where we're going to be looking at, let's say, one graph that sort of set that baseline, and then a subsequent graph that went off track from that baseline. Really what it's looking at then is again, that variation. Here's that pH graph. I'm going to come back to it again. But that pH graph that I talked about, where we were able to look at flavor impacts of a specific graph. I'll let you guys kind of guess as to which one of these three fermentation batches, 95, 96, or 97, could have been sort of the errant graph from a sensory standpoint, and I'll come back to it in a little bit. So again, the idea here overall is by providing this high frequency data, right, and setting those baselines in place, or those benchmarks in place, what you're going to be able to look at is early detection of potential issues to your fermentation, right? How healthy is your yeast? Did you accidentally overpitch or underpitch? Did you accidentally leave the blow-off valve closed, right? Are you having an issue with your glycol jacketing system that's causing you to be in free rise or accidentally cold crash, right? All of those things come with real-time data. And the free rise or accidental cold crash is something that hopefully a lot of brewers have in place, right? Because you've got essentially that thermostat on your tanks. And the point of that, most brewers recognize the importance of being able to track and see in real time what your fermentation temperature is, because it's such a key indicator, right? So now we're able to deliver that not just on temperature, but on all of these other variables that we're tracking. So here's sort of a simple case example that I'll show just to kind of start things off, right? So this is a real reckoning of two beers that I've anonymized out of the system, right? This is a brewery that brews a sort of flagship pale ale. You can see it starting there at 14 degrees Plato in the green graph, which is a healthy fermentation for these guys. And it drops down to about 3.5 degrees Plato down at the bottom end. So, this is a healthy fermentation. It lasted right around a week, right? At about 140 hours is when you're really hitting that terminal point. But truly made it there by this 168 hours. That's a full 7 days, right? So here's a week-long fermentation. It's kind of a long lag phase. That beer didn't kick off for, a good 36 hours from the look of things, right, before gravity started moving downwards, but otherwise a healthy fermentation. In gray, you can see in contrast a subsequent batch of the same beer that was tracked about a month later. You can see how the data that's tracking along there, it takes a long time for gravity to start moving downwards, right? We're somewhere probably around 80 hours before it started moving downwards. And the system finally detected motion downwards after or just shy of 90 hours, right? But then you can see how it just holds there and gets a little bit noisy, but doesn't really drop below what appears to be about 12 degrees Plato. So you've got a classic stalled fermentation there in place, right? And when you're looking at that, it would be pretty easy to tell that somewhere around hour 50 or 60, right? That you just don't have motion downwards. And you'd be able to take this data and compare it up with, say, the pH data or the dissolved oxygen data to see, is the yeast acidifying? Was that oxygen absorbed as quickly as in a sort of benchmarked batch there, right? And so this is a real case scenario where we had this brewery that had this stalled fermentation. We were looking at it and noticed it in our quality control checks that we do on a daily basis, looking through live fermentations and seeing if any of the sensors are behaving in a strange way. So we got in touch with them to say, hey, don't know if this is what you're expecting to see or not, but here's what we're looking at. Just want to make sure it's not a sensor malfunction. And they responded back saying, yeah, we had noticed that it's a stalled fermentation. There's no activity happening. So, able to sort of save that batch without it extending too long. They were able to start making decisions on whether or not they needed to dump the batch, blend it, restart it with some yeast or things like that, right? Here's another case example where you can see, like I was mentioning, the accidental cold crash. So one of the things that we like to look at is multiple sets of fermentation or multiple sets of data, time series of data overlaid on top of each other. So up top here, what you're looking at is a fluid temperature graph. in a brewery that's not temperature controlled in the middle of July in North Carolina. So a lot of high temperatures working their way into that cellar, right? But what you're looking at is actually overnight, a cold crash there starting at about hour 36. So at about 4 a.m., the brewery team here got text message or email alerts saying that their temperatures were falling well below the acceptable range. And they were able to run in early that morning and address the issue with the system and let the temperature work its way back up. Now, what's interesting to see there on that lower graph is how that impacted the gravity, right? So you can see gravity is working its way downwards, and at about hour 36, the slope of that change in gravity, the rate of gravity change, starts to shallow out there, right? Almost like fermentation's ending, because you're essentially prematurely cold crashing that yeast out of solution. Once that temperature starts to rise back up again, then you can see how the fermentation kicks back off, gets super active as that data starts scattering, and then works its way downwards again to the to eventually finish out where those guys wanted it to. So again, just being able to look at and use this data in a true way, not only to be able to interpret it for you in the way that I have here, right? But you can imagine that real-time thing of saving that pitch. I mean, this truly was 4 a.m. on a Saturday that they got this notice. You know, if they were planning to take the email or take the weekend off, right? They may not have caught this until potentially hour 72 or 84, right? Made it all the way through that weekend and gotten back into the brewery only to realize that they had this tank that had crashed on them. So there's a couple of real examples that have been anonymized out of the system, but I've also got some case studies to talk about here, right? So both of these examples are actually taken from small-time brewers. I'm talking owner-operator breweries, right? So folks that are, a married couple in the instance of this graph that we're looking at right here, that owns and operates their own brewery as a couple, or the previous one where it's a single owner-operator, right? The owner, he brews the beer up, does all the manual labor himself, right? And one and such customer, not one that with an example that I've shown you, but Denver Smith out in Poulsbo, Washington. He's a single brewer owner operator. He was kind enough to give us and share some words with us on how he's used the system. So specifically, he's looked at exactly the types of fail-safes that I've shown you here in these graphs already, right? So he's using it truly as kind of an alert system, a real-time monitoring and alert, right? To let him know in case something's going wrong, in order to save him from, having to spend 7 days a week heading into the brewery. He lives about 45 minutes away. And so this puts a lot of family time back in his hands, while also giving him kind of that peace of mind. He talks about, having this fail safe in place, keeps him from, having to stress or worry about it, because if he's got a specific batch that he started up on a Friday, right, he knows he can head into the weekend with that peace of mind of having that real-time information, alerting him if something is going sideways on his beer. Another brewery that's a little bit larger, but still relatively small in the grand scheme of things, as most of us out there are, right, is City Built Brewing out in Grand Rapids. And Rob, who as a small brewer is very focused on innovation, product innovation, and process innovation, right? So taking it even a slight step further from what Denver's doing at Western Red, which is, brewing some batches and using this system as sort of an insurance policy on it. What Rob is really interested in doing is seeing how the process is playing out, and when he's using the novel approach to brewing and doing things like heavy dry hopping or fruit additions to the beer, how is that impacting the fermentation in real time, and how is this system helping him make quicker decisions to be able to turn over and turn around beer in a more real-time way. So, for example, one of the things that he might be looking at is hop creep here. So I've got an example from a different brewery that's showing actual hop creep in action. So what you're looking at here is a gravity curve that's working its way downwards. And at about 144 hours, you can see the little diamond shape there below the gravity graph, or right on that line, is actually a manual sampling that they did and entered into the system. So what they were doing was looking at it, double checking and making sure that they were at essentially what they wanted to be as far as terminal gravity goes. Now I've overlaid the pressure graph on top of this to show you the process of what's going on. So you can see those dips downwards. Those in fact are dry hop additions, right? And so that initial dry hop addition at 144 hours, what you'll notice if you're looking closely at that graph, right, is that after that 144-hour mark where they took the gravity and added dry hops, you can see that the gravity actually moves downwards a little bit more. So this is, in fact, evidence of that hop creep, right? We're getting re-fermentation happening because of the hops being added to the fermentation. And so as that gravity is working its way downwards, right, the real question then becomes, if this is a novel process, or if this is something where you're changing the strain of hops each time, changing up yeast strains, you're doing a lot of innovation, right? The key thing you're going to be looking for there is, again, when do I hit that sort of terminal gravity point, right? You might be checking for VDKs, however you're doing that, but what's important for an important marker for when to start checking for diacetyl formation would be, when do I reach terminal gravity again, right? Is there, a precise and concise way of measuring that? And that's what our system is able to provide in this case, right? So a brewer like Rob at City Built is able to try out a new recipe, knowing that hop creep might happen to him, but with the peace of mind of knowing he's going to be able to measure that, see the impact of it, and know how that impact has actually affected that finished product or that process, to be able to truncate it or speed up that process, hopefully. Here's just another interesting graph of hop creep. This one's a little bit more visible and was done earlier on, right? Or about the same mark, 144 hours. But you can see how it took a lot longer for that hop creep to finish out. So we're looking at, in green, the gravity graph at hour 144 is when they dry hopped. And in this one, I'm just noting that the dry hop happened with the pH graph, right? So we know that hops are going to increase your pH. So you can see that little step upwards there at hour 144, right, when the gravity kind of jumps up a little bit as well before dropping back down, and that hop creep kicks in, and just takes a super long time to kind of drag that fermentation down. So again, this was actually taken from a brewery that was doing purposeful R&D on a beer. So this is a large-scale brewery with a small-scale pilot system that was plugging in the beer or plugging in the system to track that R&D or innovation process. Another example of product innovation or process innovation, right, is being able to use this type of data to do a reckoning of capacity and efficiency. So what you're looking at here are two back-to-back batches of the same pale ale that were done, where the gray graph was the initial batch that was done in a traditional way that the brewers had been using for however long they'd been making the beer. And once they plugged the system in, what they wanted to do was set that baseline, right? So they collected their traditional fermentation of that pale ale brand that they were running. And then they took and made some adjustments to their yeast pitching rates. So essentially taking and doing the full yeast pitch on their initial knockout versus splitting the yeast pitch up over multiple knockouts. And what you're looking at there then is by, I think, spreading that or pushing that yeast knockout, the initial knockout, and the initial pitch rate by increasing it and doubling it up, or by doubling up the pitch on that initial knockout on the first day, they were able to really increase the amount of or the speed, the rate at which that fermentation happened, and they were able to drop the overall time it took to reach a terminal gravity of just under 2 degrees Plato. And so you can see the difference there being that the faster fermentation took about 100 hours. The slower fermentation took upwards of like 170 hours, right? And you can imagine that for a brewery such as the one that was doing this fermentation here, if you're a brewery at capacity, using data like this to drive such a dramatic efficiency increase in the overall amount of fermentations you can get out of the same set of tanks is a huge ROI, right? So this brewery was able to shave off a significant amount of time. How many more turns on the same set of tanks can they get out of their brewery because of this, right? So it's just really about using this fermentation data, not just in real time, but retroactively or proactively, both at the same time, being able to look back on your process after it's finished to innovate and to look at novel ways of managing your fermentation to just overall increase that efficiency and hopefully capacity of your brewery. So I'm going to jump into the biggest sort of case study that we have as well, right? Because I've shown now a few different breweries that are kind of on that smaller end, that are looking to use this system. And you might be thinking, well, what about big breweries? These guys already have this kind of data being run and are already visualizing this type of data, are already using data in this way, hopefully, right? We've actually been working with Terrapin for a couple of years. They were one of our earliest sort of pilot partners. They saw some of the more embarrassing prototypes of the system as we were building it out. But Abby, that we've been working with over there for a good amount of time as the QA manager, was kind enough to share some words with us on the system and what it's done for them. So, they're a large enough brewery where they've got a full QA QC team, and what they really look at is the sort of labor savings that this provides them, in addition to the real-time information. So, it's about catching stuck or stalled fermentations early on. It's about monitoring the progress of the fermentation. It's all those things that they were already doing. And what our system is able to plug in and save them on is not just the time it takes to go to the lab or run out from the lab and take the data and bring it back to the lab, but then also building that data and entering it and building the type of analytics and visualization that gives them the ability to actually make decisions on this. So huge monthly savings for them on labor and time costs, but then also providing them that peace of mind for potential fermentation issues. So here's an example of how that might work, right? So this is back to that pH graph that I was talking about previously. So here's a brewery that has a very consistent, this is a different brewery from Terrapin, but just to give you an example of what this might look like, right? This is a brewery that actually came to us after having tracked a half a dozen or so fermentations of the same pale ale brand. And one of the specific batches had ended up with some sensory red flags, right? Particularly around ester formation. So they were getting nail polish remover, kind of an ester quality off of the beer, while they were expecting to get that kind of just red apple pear ester out of it. So we sort of sat down and dug through the data with them. We had set aside an hour-long meeting to kind of dig through all this stuff. And the first thing that we did was take the batch in question, which was batch 95, and overlay it on top of a couple other batches that they had that they said did not exhibit the same sensory issue. So we pulled up the gravity graphs, looked at those. There wasn't anything particularly to note, but when we got to this pH graph here that you're looking at, the first thing that we noticed was that Pale Ale 95, while it starts at basically the same point as the other two, it acidifies a little bit more deeply than the other two do. And you can see that acidification or the offset in pH there kind of carries on all the way through past terminal point of gravity and just kind of carries there, right? So the overall delta from start to finish was larger for this pH readings on batch 95. And so we started asking questions, pretty quickly and saying, well, hey, okay, so do you guys repitch yeast? Are you using fresh yeast each time? They said they repitch. So then the next question was, okay, what were your indicators of yeast health? Did you have a lower viability on this batch, higher viability that you're used to? Were you weighing the slurry differently, right? What was the total weight of the slurry heading into the batch? All those sorts of things. And what we got to the bottom of with them was they'd essentially underpitched. So the yeast, they thought they were within a margin of error, an acceptable margin of error on their viability during that reharvesting process. And in fact, it was that their viability was too low and caused the yeast to over-acidify. And so we had set aside an hour to meet with these guys, and in about 15 minutes had gotten to this conclusion where we had figured out what they needed to do and what would help them change that SOP to avoid this situation in the future, right? And it just really spoke to the power that this data has, not only as that real-time sort of proactive measure, but also as this diagnostic capability to be able to go back after the fact, seeing what's happened with a batch from a sensory standpoint or otherwise, and be able to look at what you might be able to change or control. And it's because you've got this data in place that you're able to see those things. So that kind of gets to the conclusion of and the point of all of this, right, is that what we see being the major capability out of monitoring fermentations in real time in this way, and out of using and visualizing this data in this sort of focused way, is that it's going to gain brewers across the board, better ability to control and manage the efficiency of their beers here. Right. So, or of their fermentations, because really at the end of the day, what brewers are doing is a manufacturing process, but it's a manufacturing process that relies on a sometimes fickle microbiological agent that may or may not work exactly the way that you want it to every single time. So it's about being able to monitor and manage those things in real time. And make the adjustments that you would need to make, both in real time, but over the long term from batch to batch to batch, in order to manage that efficiency for this manufacturing process that you're doing. And with that, I'll jump it over to any questions that might be out there. Happy to to jump into that if we have any. It looks like there are none in the actual comments section. I don't know if they're streaming in from YouTube or Facebook or anything like that, but I don't see many out there. I will say that one of the common questions that we have about the system overall is surrounds things like how does it get cleaned and how does it actually take these samples, and those are the perfect sort of questions for process-minded folks, right? So we have a CIP station that's been custom built for the system, and that we have done extensive testing on to make sure that it's working the way it needs to. We've had it successfully deployed out there for over 1.5 years at this point, with a lot of breweries that have been able to use the system. Some of the next steps for us with this type of data as well is going to be to get out there and be able to look at batch to batch variability and consistency, and help brewers manage this data and analytics over long term, right? With looking at potentially hundreds of batches over multiple years. So, and with that, I'll close things out. Looks like we don't have any fresh questions coming in or anything like that. If you do want more information, feel free to reach out to us at info@precisionfermentation.com, or check out our website, www.precisionfermentation.com, for more information. Thanks, folks.